So how do we protect ourselves from UV radiation? Well, first of all, we got to remember that what hits us is the UVA, and UVB is what comes through and hits us down here in the troposphere. Okay, we are lucky because we have this ozone. It's called the ozone layer that's up in the stratosphere, and this ozone layer effectively absorbs 100% of this UVC, and that's the highest energy. So this stratospheric ozone, so this is ozone in the stratosphere, that's beyond 10 miles up. We don't ever go there. The highest we go is maybe in an airplane or the top of Mount Everest, and that's still in the troposphere. So we don't have to protect ourselves from UVC because the stratosphere is taking care of that. So we are subject to UVA and UVB, and this is something where ozone in the troposphere. This has the tagline "Good up high, but bad nearby." So this is ozone in the troposphere is an air pollutant, but ozone up in the stratosphere is what we need. Okay, this protects us from UVC, and this is something where we have the biological effects of UV radiations are basically dependent on the energy. So is it UVA, UVB, time and exposure, that can be over decades, and also the skin type sensitivity. So skin cancer, melanoma, we know has increased over time, and in general UV radiation increased in the last 40 years because of ozone depletion. So we'll talk about ozone depletion next, but this is how we protect ourselves is from sunscreen and sunblock will allow protection from UVA and UVB. This is something we'll look at all the parts of this that are important, but this is zooming in here on a label of sunscreen. It says UVA and UVB protection. Okay, water resistant SPF, but it's important when you're buying sunscreen to make sure it has this on the label. It protects from UVA and UVB because that's what we have reaching us on Earth. So wearing protective sunscreen is one way to reduce your risk of skin cancer. Sunscreen sunblock will absorb UVA and UVB. Recommendations on SPF have to do with your own skin type, but basically sunscreen allows you to be exposed for a longer time without burning. You will still have some UV radiation, and you do need to be exposed to sun for the vitamin D, but this is something that sunscreen sunblock should be part of your daily routine. There's also other things you can do. Wear clothes, stay indoors. Sunglasses are important for protecting your eyes because you can't put sunscreen or sunblock on your eyes. And then there's also, this is the UV index. So the UV index is a color-coded scale. Okay, it's color-coded and also has numbers associated with it. It's put out by the U.S. National Weather Service on the internet, and it's typically shown right with other information like the air quality index or the daily weather report. So it's dependent on geography, location on Earth, as well as the day. So it changes every day. And it's one way to protect yourselves, like wearing sunscreen, like wearing sunglasses. You can check the UV index. And so it is also next to the air quality index in the newspaper, or I think on a smartphone. I've been told, as you know, that it is also next to the air quality index. So this color-coded scale is similar to what we've seen for air quality, but not completely. So green, yellow, orange, red, purple. So green down here is good UV days, and this is or low UV energy. And it's important to have low UV because low amounts of UV means less UVA, less UVB that's damaging. The purple is high UV, and that means more damaging UV. When we're on campus at SMC, there's actually a UV light, a meter in the organic learning garden that's next to the science building, and it has the same color-coded scale. It looks like a traffic light, but it has a couple of extra lights. So the color-coded scale is linked to suggestions that's based on the colors and the numbers. So the colors are always equal to these number values, just like air quality index is equivalent to certain number values. And so the index number values are a range, but any individual day will have a specific UV index value, like a UV index of 6 or a UV index of 9.5. Okay, so your UV index of 6 would say it's a high UV day, or a 9.5 falls in this range, and that would be a very high day. Okay, so but these are tips of how to handle what to do depending on the UV index day. Okay, and so one of the most important ones is for one of the high days or very high days or extreme high days. These are all very similar. I'll point these out. Is basically exposure between 10 a.m. and 4 p.m. is when the highest exposure to UV is going to occur. Do sunscreen and sunblock work? So sunblock literally blocks the sunlight, the UV rays from sunlight. It has compounds that physically block. So kind of like wearing another layer. Sunblock basically doesn't allow any UV to hit the skin, this being the skin down here. Okay. Sunscreen, though, is also going to have chemical compounds, and these tend to be what are very small particles, nanoparticles. And these very small particles that you can't see, these absorb UV as opposed to blocking UV. These absorb UV, so the lotion or cream or spray, all of these, what they all have is compounds in them, and they're usually going to be linked to an SPF factor. SPF stands for sun protection factor, and that sun protection factor is a number value, and that number represents how much longer your skin type can stay in the sun before sunburn. So how much longer your skin type can remain outdoors before burning. And so it's not exactly equal to the number value, whatever SPF 15, it doesn't actually mean 15 minutes. It's a factor times 15. Okay, so times the factor, and the number you start with is how much time it takes before you burn. So let's say you have a type of skin that you burn in 5 minutes. So when you have SPF 15, it means you can have 15 times more minutes than when you would have without it. Okay, or SPF 50 means 50 times more minutes than without the sunscreen or sunblock. One thing is that all SPF filters out UV. So even a low number like SPF 15, that filters out 93% of the UV. So the only difference between the different SPF values is the time factor, and the time factor is linked to how much time you would burn. So you have to basically take that into account. If you burn quickly, you need a higher SPF. If you don't burn as quickly, you don't need as high of SPF. Everyone is basically covered, but for SPF between 15 and 30, because you don't tend to be outside that long, and if you are outside for longer, you have to reapply the sunscreen or sunblock anyhow. These are some of the chemical structures that are in sunscreen compounds. So these are more complicated looking. We'll be talking about more complicated looking compounds like this. They're organic molecules. Organic molecules are carbon containing compounds. So they are more complicated, and we are going to hold off on looking at these until later. So one thing to look at on any container, brand X sunscreen, is that it should say it protects against UVA and UVB. Another term for this is generally used broad spectrum. So broad spectrum means it protects from UVA and UVB. So like the other label I showed you that actually said UVA and UVB, this means broad spectrum is the same thing. And so UV light is absorbed by electrons in these compounds. There are a lot of electrons in these interesting organic molecule shapes. And this is the green is an example. These green ones are example of absorbing UVA and UVB versus these red ones absorb only UVA and the blue ones absorb only UVB. There's not a chemical reaction with bonds being broken when UV energy is absorbed, but just a temporary change to the compound.